Hi everyone. So today we're going to discuss about a compiler optimization known as empty base class optimization. Now, before we proceed, let us have a discussion about this empty struct. What do you think the size of this struct is? Well, it doesn't contain any data members, so one might think that the size is 0. Let us compile and verify. Well, the size comes out to be 1 byte. And why do you think it happens? Well, it happens because in C and C++, every object, it must have a unique address. If the compiler, it hadn't allocated any space for an empty struct, then it would have been impossible to create distinct objects of that type with unique addresses. Like, let us create two objects and let us print the addresses now. Now you can see that these objects, they were successfully created with some addresses assigned to them which are unique. I mean, this one is different from this and is offset by one. It has happened only because of this optimization. Otherwise, it wouldn't have worked. Now let us return back to our main concept. So returning back to our concept, what do you think the size of derived struct is? I mean, it is deriving from this empty struct, and previously we found out that it contains 1 byte. So you might wonder that the size of this derived class, it must be 2 bytes, right? Let us verify. Well, it comes out to be 1 byte. So why do you think it is happening? Now, this is the empty base class optimization, which states that the compiler, it can optimize away the storage for an empty base class when it is not necessary to maintain a distinct address for the base class. Now here there is no benefit of maintaining the distinct address of this base class, so we can just optimize away the storage of that class, right? But we need to make sure that it is permissible only when the base class does not also exist as a data member within the same derived class. Let me show you. Let us say we have a data member empty class. Now, what do you think the size is? Now, you might think empty base class optimization is happening. Now, since it is there as a data member, then it must be 1 byte plus 1 byte, 2 bytes. I mean, it's a guess, right? So let us see. Now, it comes out to be 3 bytes. Now, here in this case, we need to distinguish this data member from this derived empty class. So now here two distinct objects, they need to be distinguished. So that is why we have assigned 1 byte to it. So here optimization is not working. There are also several cases where the optimization might not work, but the basic concept remains the same. So this is all about this optimizing compiler optimization. Thank you.
Bear with me, don't gotta worry for the both of us.